So, waves. We all know what they are. You can see them. You got the surfer boys up on top of them. But one of the most important things about waves is the wavelength, which is just the difference, the distance between two waves, right? So, think about a pebble in the ocean. When a wave goes past a pebble, does it change direction? No. If you're going out for a lovely swim in the summer in Kilkee, when you're walking out into the water, does the wave change direction when it hits you? No. What about a pier? Wave comes in and hits a pier. Does it bounce back? Yeah. But why? Because the pier is bloody massive, right? But what has that got to do with it? It's because the pier is nearly as big as the wavelength. You got a really big wavelength between waves in the ocean, and the pier is big, so it reacts to them. So think about sonar. You got a ship sending waves out. If those waves hit the pier, they're going to bounce back, and the ship can see, oh, there's a pier there. We better not crash into it. Then can also search for submarines under the water. It's going to send out waves, it'll hit off the submarines and go back. But ships are looking for big things, like subs and piers. They're not looking for little fishes. So the fish are going to squeeze in between the waves, and they're not going to see them. So now, taking it to something else, ships are like, brrr, but bats are like, squeak! Little squeaky boys up here. So, do you remember from school how bats see? They're blind, right? So they use echolocation. How does that work? They send waves out, bounces off things, and they can see where they are, right? But bats aren't looking for submarines. They're not looking for fish. They're trying to see little insects for them to eat. So bats are using little waves to see little things. So, small waves, you can see small things. Now we're going to think about something else. How are you seeing me? There's light coming from the light bulb, bouncing off me, and going into your eyes. But what about all the things in between us? There's oxygen, nitrogen, carbon dioxide. Why doesn't the light bounce off of those things? Why can't you see those? Well, the same way that the fish go in between the waves and the sonar, oxygen is smaller than the wavelength of light. So it doesn't bounce off it, so you can't see it. But what if you want to make microchips and things for your mobile phones that are only like 20 atoms across? How are you going to see that? That's where electron microscopy and X-ray microscopy comes in, and that's what I study in UL.